3.4 Shared Solutions. So we've learned all the methods of solving simultaneous equations, but now we're going to turn to looking at kind of the funky or different solutions that you might get. So there's three different kinds of solutions that you might get to these types of problems. So I'm going to start with the most familiar, the one you have been getting. So shared solutions, here we go. Example 1, this is a simultaneous equation. I have two equations and two unknowns. It's lined up really for me to use elimination method, so that's what I'm going to do. So I'm going to add these two together, and I'm going to get, that goes away, and I get 2y equals 8, divide by 2, y equals 4. If I plug 4 back in for y, I have x plus 4 equals 2. Solve for x, I get x equals negative 2. So my solution is negative 2 comma 4. Very much like what you've been getting, okay? If I were to show you a picture of this, this one would turn into, if I move things around, y equals negative x plus 2. If I were to turn things around here into y equals mx plus b, I would get y equals x plus 6. Okay, so now I'm going to show you, I'm going to reveal the graph because I've already done it for you. I have, this one is an intercept of 2 right here and a negative 1 slope, so it goes down. This second equation here has an intercept of 6 right here and a slope of 1, so it's growing. So the intersection point is where the yellow highlighter is, which is actually at the point negative 2, 4, just like it says right here, negative 2, 4. Okay, so that's pretty much what you've been doing. Now, we're going to get into kind of a different type of solution. Okay, so now I have two equations, two variables, and I'm trying to figure out the variables. So I'm going to proceed like I always have, and I think this one lends itself to doing substitution, because all I need to do is transfer the 2 to the other side, and I get y equals 2x plus 2, which will help me with graphing later. Go back to my first equation and plug in for y, 2x plus 2 minus 4x equals negative 8. Solve this, I get 4x plus 4 minus 4x equals negative 8. And I go to clean things up, and looks like 4x minus 4x cancels out, and I get 4 equals negative 8. Well, that is not true. 4 does not equal negative 8. So I have a problem. My x term went away, my y term went away, everything's kind of crazy. So what does that mean? Okay, well, let's say I don't know. I'm going to erase my work, except for maybe that left-hand side, because that's going to help me. And I'm going to look at a picture of this. I've got this one already turned around into y equals 2x plus 2. But let's turn this one around right here. I'm going to move the 4x over, which is going to give me 2y equals 4x minus 8. And I'm going to divide everything by 2. And I get y equals 2x minus 4. Well, this equation's y equals 2x plus 2. This one's y equals 2x minus 4. Well, what does that look like? This has an intercept of 2. This has an intercept of negative 4. This has a slope of 2. This has a slope of 2. So they're parallel. This one has an intercept of 2 and a slope of 2. This one has an intercept of negative 4 and a slope of 2. The two lines are parallel. Now remember, my goal in this is to figure out where's their overlapping point. Where do the two lines intersect? Well, nowhere. They're parallel. So the way you would state your answer is there are no shared solutions using that symbol, or you would say no shared solutions. Okay, Linus calls this inconsistent, so you will see that word in your work. And actually, I forgot to mention on the last slide that when you get an answer that is a point, that is one shared solution, that would be called consistent. I'll remind you of that in one of the future slides coming up. Okay, example 3. I have two equations, two unknowns. I'm going to go forth and solve this like I have been. I think I'm going to use substitution again. I have y equals 3x plus 1 if I move that one around, which will also help me with graphing later. And if I go ahead and change this or substitute in, I'm going to replace y with 3x plus 1. I'm going to get 9x plus 3 minus 9x equals 3. The 9x cancels out, and I get 3 equals 3. Well, guess what? Another funky solution. 3 does equal 3, though, this time, whereas before I got something that didn't make sense. So the 9x did go away. So what does that mean? So to make meaning of this, I'm going to go ahead and graph it. So I'm going to erase my work for a minute. I've already got this one in y equals mx plus b. So let's change this one around. I'm going to first move over the 9x. Then I'm going to divide everything by 3. And I get y equals 3x plus 1. Oh my goodness, 3x plus 1, 3x plus 1. It's the same. So if I go to graph it, I'm only going to have one line. These two equations are exactly the same. They don't look it, but they are what they call equivalent. So because they're equivalent, if I'm looking for their shared solutions or where they overlap everywhere. So there are infinite solutions. Okay, so those are my 3 kinds of solutions. And so if I go ahead and I look here, the types of solutions to simultaneous equations. Consistent, that would be like 2, 3. That's a consistent solution. Inconsistent, well, and it also looks like this. There's my answer. Inconsistent would mean the lines are parallel. There's no solution. No solution or no shared solutions. Equivalent means that there's only one line because they're exactly the same. So there are infinite solutions. It's not any number. Ooh, I didn't really mean to do that. It's not any number, but it is. Oh, I'm having some technical difficulties. It's not any number, but it is going to be infinite solutions. Let's see if I can clean that up. No, I'm having some trouble. So I have consistent, inconsistent, and equivalent. Okay, we'll move to the next slide and see if we can clean this up a little bit. There we go. Equivalent, and that's going to be, remember when we said it's only one line, it's a shared solution, and infinite solutions. Okay, so we have infinite solutions, we have no solutions, and we have one solution. Okay, moving forward. What method should I choose when I'm solving a simultaneous equation? Graphing is really going to be a check step because you don't want to graph unless you're either uncertain or you want to check your work. Elimination is going to be used when things line up nicely. If I have, that works perfectly. I'm going to line it up and I'm going to eliminate. Okay, sometimes the numbers don't match up perfectly, but I can multiply to use elimination, and that sometimes is the best solution. Substitution. If something already is in the form y equals 4x plus 1, and then my other equation is in a different form, then I'm going to use substitution. So try to make a smart choice as to which kind you want to use. And then looking down, the solutions can be consistent, inconsistent, or equivalent. Okay, that's all for now. Good luck.